So welcome to today's webcast on the business sense of simulation and analysis. And I will be keeping an eye on the chat panel, and we'll have lots of time at the end of the presentation to answer questions. So feel free to put them in the chat or save them for the end. And today, in 30 minutes, we're going to talk a little bit about the history of computer-aided engineering, otherwise known as simulation and analysis. And really, we're going to hone in on the value of simulation and implementing simulation in an organization, not so much the products and the feature functions today. So before I get going and start talking about simulation and Fisher Unitech, I'd like to learn a little more about my audience. So with that, we have a poll, and we'll set this for a couple minutes. And I'd like to open that poll up with just a few questions about what you're interested in learning today. This helps us make better webcasts for our audience. So you should see a window pop up on your screen. Now, I see a few of you that have not started yet, but it looks like everybody's jumping in. That's good. And we'll have a couple, actually one more poll to get your opinion at the tail end of the presentation. And we have a remaining 15 seconds. And a couple seconds left, and we'll close things out. So let's take a look at why we are here today. So I came to this webinar because I would like to learn more simulation clicks and tricks. That seems to be the main reason we are here. And let's see, my organization currently uses analysis, and you're looking for some better options. That's a good one. And it looks like a few of you have a problem you're looking to solve. And with respect to tips and tricks, I would recommend checking out my personal page as well as the Fisher Unitech blog. Lots of tips and tricks there. This is more of a high-level business value discussion today. Experience, so let me see. I'm familiar with simulation but not using the tools, and no answer is the second highest. And it looks like most of us are end users. So that's good for me to know, and good for you to know that today is, like I said, more of a high-end, talking about the value of simulation, and we will be looking at some pretty cool use cases and how companies are getting value, so you will still find some interesting tidbits in this presentation. So a little bit of CAE history to put things in perspective. And one of my favorite movies, Mel Brooks' History of the World Part 1. And if you know Mel Brooks' humor, there was never a Part 2. But this is a great scene where we've got a pitch man, and we are in Rome. And he's pitching plumbing, step right up, get your plumbing. It's astounding, it's amazing. It moves water from one place to another. You can pipe the stuff right on out of your house, jump on the bandwagon. And I love that because there is no more convincing sales pitch than jump on the bandwagon. If everyone else is doing it, usually there's a good reason for the most part. And if we look at the history of plumbing compared to the history of computer-aided engineering, obviously way back in Rome, they had viaducts and they were moving water around, but we're looking at the more recent history of plumbing as we know it today. And if we look, it's actually relatively recent. Back in the 50s, 60s, there was still some rural America. There were still, a fair amount of outhouses around. Now, if we look at the history of FEA, CAE or computer-aided engineering, really started back in the 60s. And if we see back when Cosmos Works was invented in the late 90s is when really those tools that used to be very high-end and expert users only with archaic interfaces were back in the 60s, and by the 90s simulation is starting to get democratized. But what is kind of interesting is when you look at this, FEA has existed before high-efficiency toilets. The FEA, the term was coined back in the 60s, and it wasn't until the 70s that we actually cared about the environment and started making the toilets more efficient and more better. So it's really been around quite a long time. And if you look at some surveys, so this is an Aberdeen Group report, and I believe you will get a link to this report if you'd like to look at it. But they surveyed companies, and they're ranked best-in-class industry average to laggard, and saying how many of you used some sort of CAE or simulation in your process. And you can see that the majority of the best-in-class companies are instituting simulation and analysis. Now, why is it? They're obviously getting some value out of it. And now, granted, I have mainly end users on the line, and I think as engineers, we get the value of simulation. It's actually why I chose to make a career out of it when I was a product engineer. I started using them as tools to do my job and said, this is something that's not going to go away, and it's going to be a big part of our future. We use analysis because the cost of change is lower in the design cycle. A lot of customers will start doing analysis because they have, I'll call it forensic problems where we've already gotten into production or we're already at the release phase, or we might have an installation at a customer and we might start doing some analysis via consultants to put out that fire. The ideal situation, though, is that we bring analysis up front early in the design phase, and that's where really the democratized, easier to use analysis and simulation tools come in really handy. The types of value that simulation is creating. Now, this is from an earlier webinar where I did a poll on an engineer's perspective and where we feel the value of analysis is coming from. And what I like about this is an output from an ROI calculator. But I like how it summarizes the hard direct cost savings at the top, typical cost reductions, reduction in prototype costs, avoiding current simulation tools. If you can buy some less expensive ones and not buy as many tokens or seats of more expensive tools, those are direct savings. Avoiding using analysis consultants. Those are hard direct costs. And then we have improving efficiencies, improving effectiveness. What I find interesting is that most of the people that call me for simulation are actually more talking about soft benefits. We want to innovate. We need to get to market faster, improving time to market velocity. So what I would like to do is look at a few case studies of how customers are realizing this sort of value with simulation. So one very interesting case study is Renault, and what they are using is what's called topological structural optimization. And in this case, they're using that in combination with 3D metal printing for manufacturing. Because the topological optimization is kind of a clean slate version of optimization. So SolidWorks analysis has parametric optimization, but what's very popular these days is topological. And what this does is enables us to whittle away the material that's not needed in design. So for example, in this case, just about every component on this particular diesel engine from Renault, they've gone through, optimize it topologically, so they need to have a good understanding of their load scenarios and constraints, and optimized all their brackets and cylinder heads and rocker arms, and got about 120 kilograms of mass out of this engine. And using the optimization combined with the 3D printing, the 3D printing allows them to create shapes that might not have been practical with conventional manufacturing processes. So what does this look like in software? So let's take a look at an example inside of Solid Thinking, which is a topological optimization tool that we carry, and it's called Inspire. And if you'll notice, we create design domains, and that's where we can remove material. And now from a practitioner perspective, if you just imagine multiple bodies in your model, some of them we say we can remove material, some of them are just placeholders for loads and fixtures and constraints, and then we can design or set up multiple load cases that represent our actuating or our actual environment or our loading, and optimize across those load cases to maximize stiffness or reduce mass and keep a certain factor of safety. So topological optimization, Renault is using that in combination with 3D printing. And what types of value do they get from using these tools? Well, they're obviously improving competitive capabilities. If you're lighter, you're going to get better gas mileage, and obviously you're going to be able to beat your competitors from an efficiency, cost, and mileage perspective. Improving product development productivity, reducing prototyping costs, obviously reducing the cost of the actual prototypes themselves. So lots of places they're getting value out of simulation. So when your product needs to get good fuel economy or be efficient, it needs to accelerate quickly, say an end actuator on a robotic arm is made in large quantities where saving a couple grams can save us a lot of material in the long run. If it needs to fly, obviously aerospace is a big place where we care about mass reduction. Or if it gets shipped and we have a lot of costs associated with transporting our product, then structural optimization tools make sense. And we have topological capabilities, which are more for clean slate design, as well as the parametric optimization capabilities inside of SolidWorks simulation. So another but different example or use case of simulation value is diversified engineering and plastics. And so they are in the business of designing injection molding tooling and running parts. And they use SolidWorks plastics for analyzing the process. So with Renault, we were analyzing the end product. Very often with simulation, we might be analyzing the process. And in this case, the big value that Diversified is getting out of plastics is reducing the tool tuning time. We didn't hit our dimension directly. We need to go in and massage the tool to try to hit our specs. And by understanding with SolidWorks plastic what that final net part shape is going to be, we can adjust the tooling. So in SolidWorks plastics, which would be the product we would use for this, it's very much process-centric. So if you are familiar with injection molding, it's very much templated around the injection molding process. So we're going to be able to tell how our part can fill, if we're going to have weld lines or knit lines, if there's going to be potential air traps. And if you run the simulation all the way through the analysis process, you can extract what we call warpage. What is the final shape of the part going to be? That warpage is going to be a function of thermal stresses along with in-molded stresses. And then we can send this out as a counter-deformed geometry and use that as a reference for shifting our nominal dimensions to hit our design targets. So I can take this warped version of the model, and we can say export this out. And in this case, we'll send it out as an STL with a -1. So this gives us a negative deformed STL. And this can be used as a pattern for, as I mentioned, tweaking your nominals. So we can use that STL to figure out where we're going to be a little bit proud, where it's going to have a divot or a dip, and hit our targets with fewer teardowns of the tool and going back and burning new EDMs and more machining. So, when your business is the business of making other people's designs into parts, very often you're interested in simulating the process. So this is where injection molding analysis, casting, or even extrusion analysis, we're more concentrated on the process, not necessarily the part. However, if you are a product engineer and you are building tons and tons of die cast or extruded or molded parts, analyzing the process is very good for DFM, or design for manufacture, because we all know that the more applicable our design is to the manufacturing process, the lower the cost is going to be in the long run. So what type of value do we get? Competitive capabilities. Obviously, if we can quote our tools at a lower price, we can win more jobs. Internal costs, like I mentioned, fewer trips to the machining shop to modify the tool. Avoiding outsourced simulation. Very often, lots of customers that are requesting injection molded parts are requesting analysis up front as part of the whole process. So lots of molders end up outsourcing injection mold simulation. So our last example of customer value today that I'd like to talk about is Alburty Lab. So this is another smaller company. So we started with a very large company like Renault, and then Diversified is a medium-sized mold shop. And Alburty Lab, they're a smaller company, 16 employees, and they are working in the aerospace and defense, and specifically in the realm of aerosol research. And what they design are anthrax detectors. So what they want to be able to do is actually concentrate particles so that they can detect them sooner. And so they are using SolidWorks flow simulation to track particle studies, particles of different sizes, and where are they ending up, and can we concentrate them in this detector to detect them sooner. So they use SolidWorks flow simulation to model their chamber, and there is a capability in flow called particle studies. So you run a flow simulation, develop your external flow fields, and then we can start putting in different particles of different sizes and different initial velocities and track where those end up. And since our goal is concentration and detection, whereas oftentimes people are looking to get rid of particles for things like such as air quality indices and HVAC types of simulation. So, Alburty, improving competitive capabilities. It's kind of a David and Goliath, competing against the large aerospace defense contractors. Avoiding the need to use consultants, which could eat up your budget very quickly. Improving time to market velocity. And reducing their prototype testing costs. So the cost of the actual testing, as well as the cost of generating those prototypes. So there's 3 different types of analysis and simulation value, but I really wanted to talk a lot today about implementing analysis and simulation. So, sit down and we want to look at our organization and understand where is that SolidWorks simulation and analysis value going to come from. And we do not want to be the person that starts when we have the fire. We want to be proactive. Start using simulation before we have to do that forensic analysis to put out a firefight. Think about your products and your design and your process. Where's the biggest bang for your analysis spot going to be? And I always like to sit down with the customer and do what I would call a napkin sketch ROI. Does simulation and analysis make sense? What kind of problem do we have? In here, this is just your typical prototyping development ROI. If I do X number of physical iterations, what's that cost going to be versus the virtual? And does it make sense for us to implement simulation and analysis? Always keep in mind that there are harder to quantify benefits of simulation. It's a perfect environment. You can A to B comparisons without all the unreliability that goes along with physical testing, in addition to the cost reductions that we discussed earlier. So we want to start usually with a pilot or a project where we have some experience or data. So the customers that get the biggest value out of simulation always close that loop. So we might start out without any physical data or experience, but we run our simulation and we run that project through its end and we start getting physical data. And we want to start comparing that back to our simulations. Simulation analysis is all garbage in and garbage out. The good thing is that when we compare A to B scenarios, some of these variables will cancel out. However, the only way to get better at doing simulation and having a better understanding of your inputs and potential limitations is to start comparing those simulations back to the final end result. We say that there's no harm in running prototypes or creating prototypes. The harm is really in creating that wrong prototype, and we're hoping to avoid that by picking up simulation. We want to keep the project simple. Always think of simulation kind of as a scientific method. What's my hypotheses that I'm trying to disprove? We could spend all day long simulating all kinds of different scenarios, but just like a physical test, if we don't have a good test plan set up, we could just kind of end up spinning our wheels, so to speak. Another thing to keep in mind when starting to implement simulation is, what does my team look like? That's going to kind of determine how we implement simulation. If your team has a reasonable amount of bandwidth, we have some engineering background, and ideally maybe a little bit of analysis experience, we can dive right in, maybe with a little bit of mentoring services to teach you the clicks for our specific code, but you've got good engineering fundamentals and you've run some analysis before, a little bit of mentoring can go a long way, and we can get you up and running and you can just dive right in. Now, in the space of SOLIDWORKS simulation, there's lots of people without a formal engineering degree or background that we train to do simulation. Granted, there's going to be a learning curve. However, implementation might be a little more different. This is where we might not dive in head first. We might go in feet first. And I would highly recommend, especially if you don't have a formal engineering background or it's been many years and you forgot a lot of the basics, is to take our simulation courses, because we teach simulation, and the expectation is not that you have a PhD or a master's in mechanical engineering, but these are great for the basics. And then we can also do mentoring after that to help you get confidence in your newfound skills. So you'll understand a little bit of the theory and the background and how to properly use these tools, and then we can further help you apply those tools to your process and your product. So there are a lot of benefits of doing simulation yourself. First one, you know your product better than any analyst. Whenever I work on a services project, the first thing I'm doing is just getting familiar with that individual product, and there's a bit of that learning curve. The other thing is, when I'm building these models for my customers, is by the time I'm done building the model, I very much understand the designs, and very often I think of, well, my customer would be better off doing this, because I'm getting really intimate with this product after we've run a few analysis on it and we set up those studies. The other value I find in simulation, and this is something I realized in industry very often, I'd have a project engineer come back into my analysis group and say, does this work? And I would say, well, we really got to break this down. What do you mean by does this work? And when you sit down and build a simulation model, it's a schematic of reality. And breaking down that problem very often helps you understand a better path for a solution. You know, the first phase of the problem-solving process is break your problems down. And then lastly, you know, learning simulation tools really reinforces your engineering skills. My concentration in school was dynamics and kinematics, and then eventually vehicle dynamics. I was not terribly strong in the thermal fluids realm. However, when I started running CFD and thermal analysis, that really forced me to dust off those brain cells, and now I have a much better handle on thermodynamics than I did just a few years ago. Now, let's say you don't have a whole lot of bandwidth, and you still want to start with a pilot and do simulation. We do offer services, so if you just want to dip your toe in the water and you have a specific problem you're looking to tackle, we at Fisher Unitech can help you out by running the analysis for you. Ideally, I would like to teach you to fish at a later date. In addition, if there are some capabilities that the SolidWorks or Solid Thinking or the electromagnetics tools that we sell don't cover, we also have partners that have other analysis tools and offer more analysis services. So we can help point you in the right direction. And with that, I know all the end users on the room are just dying to see more animations and videos and what are the products that we're talking about. As you can see, there's a wide range of physics and capabilities within the tool sets at Fisher Unitech. So we have the SolidWorks simulation tool sets from flow simulation, simulation standard, pro, and premium. Those include your dynamics and your static structural analysis. In addition, we have the Solid Thinking Inspire topology optimization tools, the casting simulation, and extrusion analysis. And we also have electromagnetic simulation. We have products from EMWorks. They have low frequency and high frequency magnetics. And if there's something here that you don't see, odds are we have a partner that can help you out. So a quick poll before we wrap things up today. I think we're right around a half hour. Is I would like to see from your perspectives, where do you see simulation value? So we have A, cost reductions, so reduction in prototype costs, avoiding simulation costs. Those are the hard savings. We have improving efficiencies, so fewer change orders, reducing the testing costs associated with doing prototypes. And then we've got the soft benefits, improving effectiveness, getting market faster, trying out more ideas with less risk, differentiating and innovating. So we have A, B, or C. So for those of you that I haven't lost yet, I will open up the poll. Let's see. Now I can run all kinds of analysis tools. Let's see if I can run a WebEx. So this one is very simple. Where do you see the value? In A, B, or C? Cost reductions, efficiencies, or effectiveness? And we will open the poll for 2 minutes. So we'll do 1 minute. There we go. So I'm going to close the poll up. So it looks like the majority of us found number C to be the largest value. Whereas interesting, the last group that I had was more along A and the hard costs or the tactical savings. So interesting stuff. So I'd like to thank you for spending time with me today, and also remind you that you can follow us on social media. Our Fisher Unitech blog. I do write blog posts almost monthly with fun simulation tips and tricks and other simulation analysis info. And you can also check us out on YouTube, Facebook, Twitter, and LinkedIn. And then also another reminder, you can follow me on LinkedIn. I will oftentimes post interesting tips and articles with respect to simulation. And if you are looking for more tips and tricks and kind of fun analysis videos, you can check out my Fisher Unitech personal YouTube channel. And there's lots of short videos where I'll answer customer questions, usually with a video reply. So with that, I will open up for questions. I will take a look at the chat panel. And if you have a question, if we need to unmute you, we can do that also. I'm looking at this participant panel. I recognize a lot of these names, and it looks like I'm preaching to the choir to quite a few. And let's see. Okay, so it looks like there's no questions on the value of simulation. And keep in mind, for tips and tricks, there's support hours and our YouTube channel. And don't forget that we also offer simulation mentoring. If you've taken our standard classes and you'd still like a little more help on analysis, we can do that. So thanks again for stopping in, and everyone have a great rest of your day and week.